Okay, so let's start by counting the shoots. So the first month produces 1. The second month produces 1. The third month produces 2. What about the fourth month? 3. And the fifth month? And the sixth month? Who knows the next one? 21. How'd you do that? She added the 2 previous. You see it? Okay, so let's try, thank you. Let's try and find a formula. All right? It's under that box. You're right. Let's look at a sub 3. How did we get a sub 3? We did a sub 1 plus a sub 2, right? Which was 1 plus 1, which gave us 2. So how do I get a sub 4? A sub 2 plus a sub 3, right? Which is 1 plus 2, which is 3. So how do I get a sub n? No. I don't know what it is. It could be any of them. Yes. Good job. 2 back plus 1 back. Good job. You see it? Okay, so this is called a recursive formula. The formula for a sub n on this specific recursive formula is a sub n minus 2 plus a sub n minus 1. Yeah, there's all kinds of them. But notice what's different about a recursive formula compared to like an arithmetic sequence. What happens with an arithmetic sequence? By bigger by how much? By a certain amount. What would we call that certain amount? A common difference. What's the other one? What's the one that involves rate? That's geometric. Now you see how these are different? See how it's not always the same rate? It doesn't have to do with the rate, it has to do with the 2 previous terms. See what I mean? But it's not always going to be add them together to get the next one. There's all types of creative sequences. Okay. So this sequence is actually called something famous. This is a Fibonacci sequence. What? We'll get there. That's Pascal's triangle. Yeah, we're getting there, which is cool. I really like this stuff. I really think it's fun, although I'll show you at the end the part that I don't like because it takes a lot of creativity. And I'm not good at it, but some people are really good at it. Like Evelyn immediately saw that it was just 2 numbers being added. And some people's minds work really, really well that way, and they just see patterns, and some people's don't. I'm one of those people that don't, right? I mean, I see patterns with some things, but I think there's just, when I had to take a class where we just basically did sequences like this, yeah, it was hard. And I probably just telling myself I don't like it. So, these are found in nature. Naturally, you have Fibonacci sequences. This isn't just like a drawing, this actually occurs in a Fibonacci sequence like that, where one term depends on the previous 2. Okay? I will show you. All right, use a recursive formula. So here's a different recursive formula. Here's the formula right here. It's kind of hard to see. So in order to find the next term, right, that's how we have this written out. That's not exactly how we had it written out. So in order to find the next term, I would have to plug 1 into here. we'll see. I'm not going to plug. I have to plug another one in there to find the next one. I have to plug the previous one in to find the next one. I'm going to show you. Just put your pencils down. It's all going to unfold for you in just a second. I didn't explain that very well right now. Okay. So, in order to find, I know what a sub 1 is. It's find the first 5 terms. Find the first 5. Well, we already have the first one. What is it? It says right there, -1. So in order to find the next term, I'm going to use this formula right here. Well, it says a sub n plus 1 equals this. What if I did this? What if I substituted n for 1? If I substitute n for 1, don't I have to put n for 1 over here as well? You'll see. Does everybody agree? To make it equal, if I make that n1, I have to make this n1, correct? Yeah? So doesn't that make a sub 2? And don't I already know what a sub 1 is? It's -1. So this makes -2 plus 4, which is 2. My second term is 2. So what if I want to find 3? Plug in 2. So a sub 2 plus 1 equals 2 times a sub 2 plus 4, which is, what is a sub 2? We just found it. 2, which is 8. There's your third one. A sub 3 plus 1 equals 2 a sub 3s plus 4, which gives you 2 times 8 plus 4, which is 20. There's your third one. Go up here. A sub 4 plus 1. I don't think you need to write this. I'm going to make you guys do 2 of them. Okay? Because I really think instead of just writing what I did, you should just do it a couple times, and then it'll be pretty easy for you. Okay, so a sub 4 plus 1 is 2 a sub 3s. Sorry, 2 a sub 4s plus 4, which is 2 20s plus 4, which is 44. So there's your first 5 terms. Okay? I'll make sure this is saved and posted on School Loop. Ready to do it on your own? Yes, smaller. Of course we are. That's how we learn. A sub 1? It's right there. So I could get a sub 2. Make sense? Where? This one? N has to be greater than 1. Because if you make n -1, -1 plus 1 is 0. You get a to the 0. And we can't do a to the 0. Right? Make sense? Okay. Everybody good? Ready to start one? Okay, let's cover this one up. And try that one on your own. I'll highlight the formula for you. Here's the formula. It's kind of hard to see with all this, right? There's your first term. That's how you're going to find your second term right there. Okay, so here's the answer to the first one. 12, 9, 6, 3, 0. That's how I found the first one and the second one. Let's do this one. So if I want to find a sub 2, which is really a sub 1 plus 1, right? Which is really a sub 1 plus what? N? What is N? Oh yeah, that's right, we plugged in 1. So a sub 1 plus 1 equals a sub 1 plus 1. Does it help if I put parentheses right here? Does that make sense? I think I should write it the other way I was doing it. Let's do it this way. So if I want to find a sub 1 plus 1, I need to do a sub 1 plus 1, which is, what's a sub 1? Negative 3 plus 1, which is negative 2. Let's do the next one. If I want a sub 3, I would just do a sub 2 plus 1, which is a sub 2 plus 2. Because then n is what I'm substituting in, is 2. So equals, okay. Yeah. Where's my schedule? What Charlie do with my schedule? I don't know. It might be back there. Thank you. You guys rock. Okay. So what is a sub 2? Negative 2. What is negative 2 plus 2? 0. You guys got it? Do one more? Absolutely. So if I want a sub 4, I'm going to plug in a sub 3. So a sub 3 plus 1 equals a sub 3 plus whatever n is, which is 3. Right? That one's got to match that one. If I'm going to substitute in a 1 right here, I'm sorry. If I'm going to substitute something here, if I want to substitute something in here, I've got to substitute it here and here. The same thing. All of them have to be the same for this to work. Does that make sense? So since I put a 3 there, I got to put a 3 there, and I got to put a 3 here. I already know what a sub 3 is. We just found it. It's 0. So I get 0 plus 3, which is 3. Questions? No? We're good? Okay. Pencils down.
No.
I knew you were going to start complaining.
Yeah.
You don't even want to start yet. Just save the complaining for about 10 minutes from now. Okay? Ready? Open that mind up as much as possible right now. Okay? Going to exercise those brain muscles right now. Ready? All right. So a pharmaceutical company is experimenting with a new drug. An experiment begins with, oh, that's key right there, right? Begins with is probably going to be my a sub 1. Begins with 1.0 times 10.9 bacteria. A dose of the drug is administered every 4 hours, can kill, so that's probably going to have something to do with something, right? 4.0 times 10 to the 8th bacteria. Between doses of the drug, the number of bacteria increases by 50%. Write a recursive formula for the number of bacteria alive before each application of the drug. So, here's how this goes. First of all, let's consider the fact, do I have these in backwards? That, let's go work our way backwards. Increases by 50%. If something increases, you're adding 50% to it. Well, if you add 50% to something, how much do you end up with? Half more, which is how much total? Which gives you 150%. No. No.
Oh, you increase 150%.
You're increasing it. You take 100% of something, and if you increase it by 50%, isn't it now 150%? Money. If you have $100 and you increase it, how much is 50% of $100? $50. So how much do you have now? $150. Make sense? Good. Thank you. Are you giving me a thumbs up on my teaching? Awesome. Okay. Keep that in mind right there. Okay, increases by 50%. Okay, let's back up here. Administered every 4 hours. First of all, we're talking about this whole bacteria thing, right? At a certain amount. Ryan? Okay, I don't know. It looks like you're sleeping. So, let's make B to the N. All right? The amount of bacteria. You guys ready for this? So this is saying that there's something that's been administered every 4 hours, and when it administers, it kills off a certain amount of bacteria, right? So I take this certain amount of bacteria, and how would I kill off that much? What? Well, let's not jump to any conclusions. Okay. Let me just get there. What do I do next? What am I going to do with this 4.0 times 10 to the 8th? Subtract it. I'm going to take the amount of bacteria and I'm going to subtract it by 4.0 times 10 to the 8th. Okay, there's our basic one. But just wait, there's one more piece of it. Right? That's B to the N. Well, how do we get to the next one? Here's the formula right here. How do I get to the next one? Let me give you a hint. Right before you take a certain amount of bacteria and decrease it by this much, something happens before that. It says a dose of the drug that's administered every 4 hours can kill that much bacteria, but between doses, the number of bacteria increases by 50%. Say it again. Okay, you're almost there. You're thinking in the right direction. You're going to take, a jump happens first, which is a jump of 150%, which is 1.5. Correct? So 1.5 times B to the N minus 4 times 10 to the 8th. There's your formula. You just kind of follow me how I did it? We're not done yet. Are you kidding me? Okay. So I'm going to take that formula. That's what A said, right? That should have been your first hint right there. A. Write a recursive formula. What do you think we're going to do with this recursive formula? We're going to use it. Now, I'm not requiring that you write that down because that's straight out of your book. It's broken down for you how to do it. For that one. So it shows you step by step, almost more than I showed, but sometimes more isn't better, right? So. Okay. All right. So find the number of bacteria alive after the before the 5th application. Okay. So I already found the first one. They gave us the first one. What's the first one? What's B sub 1? 1.0 times 10 to the 9th. That's b sub 1. Begins with that much amount, right? So I'm going to take that, drag it over here with me, paste it over here. We're going to take that and use it with this. So I know what b sub 1 is. How am I going to find b sub 2? Add a 1. b sub 1 plus 1 equals 1.5. Ooh, I didn't do something that I should have done. Before we do that, let's distribute. 1.5 b to the n minus, that becomes 6.0 times 10 to the 8th. Yeah, that's distributing. Really. Are we good? Okay. Okay, moving on. So if I want b sub 1 plus 1, I would just substitute. I know what b sub 1 is, right? Ready for it? The first one's the hardest, the next one will be easier. We're not going to go all the way to 5. All right, so just watch what I'm doing. So 1.5 times, what is b sub 1? 1.0 times 10 to the 9th minus 6.0 times 10 to the 8th. This is just decimal places. Don't think of this as being something way crazy. This is 1.0 times 10 with a decimal move 9 places. That's what that's saying. Yes. I was just saying that as you had your hand raised. Right? This is 1.5 times b to the n, and this is 1.5 times 4 with 8 zeros behind it. That's what that's saying. Does that make sense? It's just shorthand. Do you want to write 10 with 8 zeros behind it? Okay. So we'll leave it like this. Okay? This is scientific notation. Yeah. Yeah. Okay. So that means 1.5 times 1 is just 1.5 times 10 to the 9th, and we're going to play with those decimals right now. Okay? Just for you. Just for Evan. All right, I can't compare these two because one's 10 to the 9th, which is 9 zeros, and one's 10 to the 8th, which is 8 zeros. So why don't we borrow one of them? Can't I do this? 1.5 times 10 times 10 to the 8th? Didn't I just take one of the 10s and give it to the 1.5? I can do that, right? Does that make sense? You guys with me? Does everybody see what I did? I borrowed one of the zeros. This is really saying 1.5 times 10 to the 9th. That's what that says. I split it up to a 10 and a 10 to the 8th. This is like saying 10 times 10 times, do you want to write that? No. Okay. So I took one from it and made it 10 to the 8th. So that makes this 15 times 10 to the 8th minus 6 times 10 to the 8th makes how many 10 to the 8th? No. 9. 10 to the 8th. This should have a 0 behind it to be proper. Right? I'm trying to be proper. Let me be proper. Be proper. Okay? Does everybody see that 15 10 to the 8th minus 6 10 to the 8th is 9 10 to the 8th? Okay. There's 2. We're almost ready for the complaining to start. You guys ready to start complaining? That's why they paid me the big bucks.
Make curvy lines.
Right? To make curvy lines. Okay. Not really. No big bucks there. All right, what do we want to find now? The third one. So what am I going to use?
Oh, wait a minute. That was one.
B to the 2 plus 1 equals B to the 2 plus 1 equals what? 1.5 times B to the 2, right? Minus 6.0 times 10 to the 8. This one will be easier though, because check this out. 1.5, what is B to the 2? 9.0 times 10 to the 8 minus 6.0 times 10 to the 8. What's going to make this one easier?
So if they both have the same thing, it's going to be simply smooth sailing.
Yes, smooth sailing. So 1.5 times 9 is how much? 13.5 times 10 to the 8 minus 6.0 times 10 to the 8 makes how much? 7.5 times 10 to the 8. Now, couldn't you pretty easily find b to the 4th and b to the 5th? Thanks, guys. Okay, so can we leave that for online and book work, right? Or we don't want to waste our time writing this down. Okay, so this is the same type of thing, only much easier. Okay, so find the first three iterates, x1, x2, x3 of the function f of x equals 2x plus 3. And to iterate a function, an iteration is the process of composing a function within itself repeatedly. Do those words sound familiar to you? Repeatedly. Composing functions. Remember composing functions? We put one inside of the other. Remember that? It's the same thing. So, if I want to find x of 1, x of 2, x of 3, and they give me x of 0, how do you think I'm going to find x of 1? Plug in what? Plug the first one in. Plug the initial one in to get the first one. Here's your formula right here, right? X plus 3, what am I going to put in for x? 1, which makes 2 plus 3 is 5. That's x sub 1 is 5. So what do you think I'm going to do to find x sub 2? Plug in what? Plug in x sub 1, which is 5. 2 times 5 plus 3 equals 13. Not bad, right? How do you think I'm going to find x sub 3? Plug in f of x sub 2, which is 2 times 13 plus 3, which is 29. There's your first 3. Not bad, right? Made what we did just right now. If you have one of those problems. Okay, what did you learn today? We learned recursive, special types of sequences. Where do you think iterate function comes from? I always think of it as reiterating something like over and over again. Okay, so let's write a recursive formula for the nth triangular number. So take a look at this. We're going to open this up a little bit. And I just want you guys to see it like this. What's a sub 1? What's a sub 2? What's a sub 3? What's a sub 4? What's a sub 5? Try and find a pattern. Does anybody see it? What? Okay. So if I want to find t to the n, what would I add? Whoa, whoa, whoa. I just heard somebody say it. T to the n minus 1. So if I wanted a to 3, I would add t to the n minus 1. What is t to the n minus 1? 3. What would I have to add to it? I would have to add 3. What was I trying to find? T to the 3? Look at it. If I want to know to 5, I would add the 1 before it, which is 10, plus 5 is 15. You see it? Hard, huh?
Yeah.
Okay, you guys did great.
Yeah.
Yes, I'll get your homework back right now.